Alright, and today I will talk about another important element in communication system, which is noise. Alright, what is noise? Let's look into our previous discussion on communication system elements. Alright, so basically in communication system, we have these three important elements, which is the first one is a transmitter, and we have a receiver on the other side, and we have a channel or medium that connects between transmitter and receiver. The other important element that exists in communication system is what we call as noise. Alright, so normally noise can actually exist not only in channel, right, but it can also exist in transmitter and on receiver side. But as for discussion purpose, I just noted this noise into the channel elements. Alright, so what is noise? See, alright, it's something you don't like, right? If you hear noise, you feel uncomfortable. So in communication system, noise is defined as an unwanted form of energy or signals which tend to interfere with reception and reproduction of the signals, right? So this is the definition of noise, which is it's actually an unwanted signals which we don't want it to be in our communication system, but actually it exists. Alright, so what type of noise that is available? So noise type can be categorized into three big categories. The first one is external noise. Second one is internal noise, and the last one is we call it as a miscellaneous noise. Alright, so external noise is originated from outside of the communication system. Alright, this is from outside of the communication system, whereas the internal noise is created by any active or passive components in communication system. Is come from the communication system itself, whether it is from the transmitter side, from the channel, or from the receiver side. Alright, and the last one is miscellaneous noise. Alright, what are the types of noise exist under the external noise? So we have industrial noise, or sometimes we call it as man-made noise. Alright, this is a noise that originated from our surrounding, car, vehicles, factory, and so on. And we also have the atmospheric noise, which caused by lighting discharges or any natural electrical disturbance around us. Alright, this also produces noise. And we also have extraterrestrial noise, such as from the solar. For the internal noise, the first one we have resistance or thermal noise, which noise that produced by any resistive elements within our communication system circuits. Alright, and then we have short noise, which is actually randomly movement of electron in transistors will produce this noise. And also the transit time noise also produced by the element of transistor or amplifier. Alright, okay, and the last one is a miscellaneous noise, which produce flickers and also partition noise. Okay, these are the noise type. Alright, so let's go into the definition of a number of parameters that can be measured related to the noise. So the first one is signal to noise ratio, or it can be written as SNR, or sometimes it will write like this, signal to noise ratio. Alright, the same things. All right, before that, we are familiar with this system. So every time we're dealing with electrical system or any electrical networks, we basically have the input side and also the output side. All right, so as for the input side, we have a signal power, input power signal, and we also have a noise input power, okay, on the input side. And then on the other side, which is output, we have a output power, output signal power, and then we also have a output noise power. All right, so you have this parameter. Right, let's see how we can calculate signal to noise ratio. So signal to noise ratio, as the name suggests, is actually the measure of signal to noise ratio. Okay, sorry, ratio. All right, how to calculate SNR? So if you look at this just now, so we have on the input side and then the output side of our electrical networks. So by this, it means we can have two type of SNR, which is SNR for input, and then we have another SNR for output. Okay, so SNR for input is calculated by the ratio of input power signal divided by the power of input noise. Okay, so this is for SNR input. Similarly, for SNR output, we have power of output signal and then divide by power of output noise. Okay, so this is the formula for SNR input and outputs. So SNR can be measured in decibels. All right, so in decibel, okay, the units of noise in decibels. So the SNR, okay, SNR in this decibel is similarly just like now. So the change is we have 10 of log 10, whether it is a SNR input or output, so we just take as a signal power divided by noise power. Okay, so we have now in decibel, SNR can be calculated using this formula. So as you can see just now, the power is actually come from the electrical system, so we can actually calculate the SNR in terms of power in voltage. Okay, so power in terms of voltage can be calculated as this one, right? So signal power equal to voltage signal to the power of 2 divided by R, and then the noise power is equal to voltage of noise divided by R. So the SNR in dB in terms of power in voltage can also be calculated as 10 log 10 P signal power over noise power, which is equal to 10 log of 10 signal over R divides the voltage of noise over R. Okay, so we can cancel out this R. Okay, and then this equation will become 10 log 10 signal over noise power of 2, and then this power of 2 we can bring to the forwards, all right, to become 20 log 10 V signal over V noise. All right, so this is how you can calculate signal to noise ratio, whether by using power equation like here, okay, or we can also use the calculation in terms of the voltage. All right, there are two types of calculation. Okay, so what means by this SNR? So the higher the SNR, okay, the higher SNR is good for transmission and receiver side. Okay, so which means our signal is much more stronger than the noise. So that means higher SNR, and it's good for our communication system. All right. Oh, sorry. So electrical signal, we done this. Okay. Okay. And it's another one. Okay, next I move to another calculation or another parameters in a communication system regarding the noise. So apart from SNR, we have another parameters to show the strength of our system against the noise. So the parameter is called noise factor and noise figure. Okay, so the noise factor is the ratio of the input SNR to the output SNR. So the noise factor, commonly expressed by F, is the ratio of input SNR, okay, SNR inputs divided by SNR outputs. Okay, so we have seen the calculation how to calculate the SNR previously. Okay, and then this noise factor, then we can calculate as a P input over P input signal noise divided by output power divided by output power noise. Okay, so actually we can have something like this: input signal, power of input signal over the power of output signal times by power of output noise, power of input noise. Okay, so so this is a calculation for noise factor. So as for the noise figure is actually noise factor that expressed in dB. So we calculate noise factor in decibels. So that is noise figure. So noise figure in decibels dB equal to 10 to the log 10 noise factor. Okay, so this is a calculation of noise factor. Lastly, the lower, okay, as for the noise factor or noise figure, the lower is better. So we want to make sure that our system will have a very low noise figure in order to produce a good transmission and receiver of communication data. All right, So that's it for this subchapter, which is noise. Next, we will try to solve a few of questions or problems regarding the noise in the next lecture. Thank you very much.